So in the first part of this discussion, we had that I is rho plus sigma, where this rho goes to 0, therefore sigma goes to I as lambda goes to 0. But what about sigma? This sigma is some I changes from 0 to n minus 1. Here we have f at xi, and here we have integral from xi to xi plus 1 g x dx. This integral here may be introduced, can be introduced as some changes from 0 to n minus 1 fxi as capital G at xi plus 1 minus capital G at xi, where we have kept the notation for capital G in our first part of our discussion. So, okay, as a reminder, g of x is integral from a to x gt dt. Now, this equals some I changes from 0 to n minus 1 f at xi, g at xi plus 1, and minus some I changes from 0 to n minus 1 f xi times gxi. But here the index I plus 1 will be denoted by some j, and this means that j will change from 1 to n. And here we will have f, j is I plus 1, so this means that I is j minus 1. So here we will have f at x, j minus 1, and here just x at j. But then substituting back j with I, we will have some I changes from 1 to n, f at xi minus 1 and gxi here. The second sum is the same. We just copy it here. Now, this difference can be introduced as some, let's take I from 1 to n minus 1, here f at xi minus 1 minus fxi, and this difference times gxi, and then plus, when we have I equals 0 here, we have f at x0 times g at x0, but x0 is a, therefore g of a, since g of a is 0, we will have 0 for the case when I is 0 here. But that means we don't need to consider that case. I mean that summand is not considered at all because it is equal to 0. But the summand when we have I equals n in the first component of this expression will be written here. So xn minus 1 times gxn. Now, what we get is that sigma is equal to this expression here. Okay, now we will use the fact that f is decreasing. Since f is decreasing, this difference here, fxi minus 1 minus fxi, is always positive. And since f is positive, f at xn minus 1 is positive. Therefore, if I substitute capital G by its maximum value, I will get something larger. If I substitute capital G everywhere by its minimum value, small m, according to our notations in the first part of our discussion, then I will get something smaller. Therefore, we get the following inequality that after some simplifications here, yes, because if I substitute gxi by capital M, it comes out of the sum, and here everything will be cancelled out except for, considering this component as well, except for f at a, f at x0, which is f at a. Therefore, I am getting that m times fa is less than or equal to sigma, and this is less than or equal to m times fa here. erase this first part, everything. Now, sigma goes to I when lambda goes to 0. Therefore, we have the same double inequality for I as well, m times fa. Then I divide both sides by fa of this double inequality, and I can do that because f is strictly positive. So I get m is less than or equal to I over f of a, less than or equal to capital M. This will be denoted by some mu, and therefore I is mu times fa. And because mu is between m and capital M, mu, and this is m. This is maximum value of gx on AB, and this is the minimum value of this continuous function, capital G. Therefore, this means that there exists some xi from AB, so that mu is f of g of xi. So what we have here, that I is g of xi times fa. Now let's recall what is I. I is integral from a to b of the product of f and g. And this is now seen to be equal to fa times integral g of xi is integral from a to x gx dx. So this is exactly what we needed to prove, what we needed to see.